Okay. Today we have invited 3 speakers to give you an overview of grassland management and forage production across Europe. But before we start and I introduce the speakers, I would like to ask you to join a little Menti quiz to understand better who's in the room, who's joining today. For that, please join menti.com and the number is in the chat. I will now share my screen so you can all see what we're doing. Okay. Great. So can you see the screen? Great. Did you already join for the Menti quiz? So the first question is easy, I hope. Where are you from? I've just included the European map. So if you're outside from Europe, just put your dots somewhere in the ocean. So we know there's from far away people joining. Okay. Nice. Bulgaria, Greece, France, Italy. Okay, for now we have most joining from Bulgaria, I see. And Latvia, nice. Okay. 14 people. So for the new people joining, just please join the Menti. There will be a few questions, well, 3 questions, just to understand who's in the room. Spain, so do we have from every country one yet? No, there's still some countries missing. Well, I'm here from Germany, so I can also put that in. Okay, nice. Well, then I will go to the next question. Which of these roles do you feel or do you identify most with? So I looked up the climate firm demo, climate smart advisor role. So what is your role? What do you consider yourself as? Okay, climate smart advisor, great. Researchers, okay, quite some researchers. Okay, if you have multiple roles, just choose one. One pilot demo farm in the room, great. And one other farmer from outside of the climate farm demo network. Okay. No one from education, media, or EIP Agri, I see. Wow. Nice. Okay. A lot of advisors, advisory service, climate farm advisors. So that's the main audience here. Some farmers, maybe some advisors are also farmers, but identify more as advisors. And quite some researchers. Great. Okay, last question. How deeply are you involved in grassland management and fodder production? On a scale of 1 to 5, how do you agree? This is my main concern all day, or you have nothing to do with it at all? Okay. Well, so I see most of the people have some involvement with grassland management and fodder production and don't feel this is not at all for them. So I'm happy to see that. And that was all from my side. I will stop sharing the screen now. Thanks for joining the Menti quiz. Where do I do this now? Here. Okay. So today we will have 3 speakers. We will have Alessandro Sita from Italy. He's the thematic lead of forage production, and he will start with his presentation. And following, we will listen to Céline Chatella. I hope I pronounced this correctly. She's from IDEL and from France, so she will present some insights from the French grassland management and forage production. And at last, we have Dr. Ralf Loges from the University of Kiel, and he will present some insights from Germany. So that's from my side. I will give over to Alessandro. It's the stage is yours.
Okay, thank you, Siw. Hello to everyone. I'm Alessandro Zatta. I'm a senior researcher at Research Institute of Animal Production in Italy, Reggio Emilia. And I will share now my screen. Okay, can you see? Perfect.
Yes.
Okay. Yes. I organized with Siw this webinar, and my argument is the forage production and climate change in Mediterranean area. And okay, the idea was to start how the climate is changing now in our area. And okay, the climate is changing in temperature, of course, and in rainfall. We have an increase on the average and maximum temperature, especially in the summertime, but also in the winter time. We have an increased frequency of extreme weather event. That mean heat waves, long drought period, and episode of heavy rainfall. In general, in Mediterranean area and especially in Italy, we have a reduction in average of annual rainfall and river flow. So that means there is the possibility to lead into a decrease in agricultural productivity and also the loss of natural ecosystem. Just to give you an idea how the climate is changing in Italy, this graph. So you can see there is the North Italy, Center Italy, and South Italy, and this is the 2022. This is the average temperature in the last 50 years, so from 1961 to 2020, and this is the different temperature according to the average. So we can see in 2022 the temperature is higher in the winter time and in summertime in both years, 2022 and 2023, and was higher from 1 to 2 degrees. So this is in North Italy, South Italy, and center of Italy and south of Italy. And we can see we have only a small decrease of temperature only in May and April. And we can see in the next slide, this is linked to the heavy event like heavy rain. We can see the rainfall. So it's the same scheme, 2022 and 2023. And the month, we can see the rainfall decreased according to the average in a lot of millimeter less in the winter, spring, and also summertime. In both years. This data was published by ISPRA. And we can see about the extreme event. Here we have the very higher rainy that is linked to the flooding event, very big, that we had last years. Just to give you an idea about the picture, how our city in Emilia-Romagna, our region Emilia-Romagna was a really, really bad situation. And another important things that I would like to underline is that this extreme event followed the very drought winter. So we can see how was for example, the mountain in a winter time. So no snow, and that was very, very big problem concerning the water stock for the agricultural production. So just to give you an idea how the climate change, the event of climate change that we are looking in Italy. This is another this slide want to explain that is, yes, I apologize because it's in Italian, but was made by our regional agency on climate, and just to they produced this very interesting map of the event that we had last years in our region. We had, for example, very dry April. March and April was very dry, and we had a minimum water content in the Po River. That is the main river that we had in Italy. And then after this very dry months, we had a very heavy rain, where 23 flowers go outside go outside, and we had more than 65,000 landslides. So part of our mountain fell down. It was a very, very, very big problem. It is up to now a very big problem. And the very interesting thing is that we had a very drought situation from 2021. So we had 2 years of drought situation. In July, again, a very heavy storm with very, very windy, and was August and September. October and December was the highest month, highest hot month than 1961. So this is just to give you an idea how the extreme event, we pass from very drought situation to very rainy situation and a very high temperature. Which is the effect on agricultural production. Okay, this is a picture that was published by European Agency of European Environmental Agency. I apologize, sorry. And in the Mediterranean region, we can confirm this data. So we have an increase in water demand for agriculture, decrease in crop yield due to the lower rain, and also an increase in risk for livestock production. Also because we have to remember that we are here for forage production and grassland management, so we have to focus a little bit on livestock sector. I don't put my focus on the border region and continental region because there are the other 2 speakers that will speak on that. Okay, forage production. Yes, for production that means breeding, and my presentation will focus on breeding, forest system, and soil. Why? Because agricultural and livestock production generate, we know, greenhouse gases. Now we know the agricultural sector impact for more or less 8% of the greenhouse gas emission. But we also have to underline that the return of livestock manure to the soil and for example, multi-year crop result in the sequestration of carbon in the soil in non-volatile form. So the livestock and agriculture can, in fact, can contribute to reduce, to mitigate the climate change through the stock carbon in the soil. Another positive effect of forage system on carbon sequestration and its storage in the soil and cannot be separated from the assessment of greenhouse gas emission from livestock. So, how to produce forage with the climate change? We identify three main area, we can say the three main area for the mitigation, three main strategy for mitigation and adaptation strategy. The first is reduce deep tillage. We mean plowing, because it's a high cost, limit the soil bearing capacity and the lifetime working time. So because if we plow, sometimes we need more time to work the soil. And the strategy is the minimum tillage and or no tillage techniques. Another strategy is to increase the biodiversity in terms also of crop rotation, of course, and to identify crop and genotype adapted to a new weather condition. For example, I just put this small note in example from South Italy, because we will see later we are trying to cultivate some species that usually are cultivated in South Italy. We started to cultivate to test it in the north of Italy, for example. Another technique about the biodiversity is also the crop association. So association, for example, lucerne alfalfa with panicum, or forage with pea forage. So crop association. And another strategy is the rational manure management. So what that mean? That means it is important to use mature manure and slurry in order to reduce greenhouse gas emission, and also to give to the soil the good products, and also spreading time according to the crop needs. So we have to spread the manure and slurry when the crop needs it in terms of nitrogen, of course. Now, we identified the three main strategy, and now I will show you part of the project where CRPA was involved, and part of this where we applied these strategies, and how this strategy contributed to better understand the potentiality of the livestock sector to reduce the greenhouse gases. The first project is a life project. The name is Forage for Climate. Forage system for less GHG emission and more soil carbon sink in continental and Mediterranean agricultural area. So this project aims to demonstrate that agricultural system, in fact connected to the milk production, can contribute to climate change mitigation. The project described the milk production in three Mediterranean areas, so Po Valley, Sardinia, and Greece, where was analyzed 87 farms, and that was grouped into 14 forage systems, which were the expected result of the project. The expected result was the mitigation strategy, is to identify the mitigation strategy and good practice of production, with increase the carbon stock in the soil and limit the greenhouse gas emission. And also the tools, to identify the tools for accounting emission and removal for the farmers, and awareness of the agricultural role in the mitigation climate change. The project activity and results. Okay, as we saw in the previous slide, we identified 14 forage systems. We analyzed the environmental impact of 87 farms. We identified the mitigation and adaptation practice. We published the result, and also we tried to quantify the soil carbon sequestration, and also we identified tools to understand how this practice can help the farmer to reduce his impact. The project was organized in three main steps. So preparatory action, so mapping and evaluation of the emission of each farms and its soil carbon stock. There was a part that was an implementation action. So we identified the mitigation strategy and good practice, and this and we also prepared a protocol for each demonstrative farm. That was 36 in total, and they applied this practice to its farm. And then the final part was the communication and the dissemination of these results through the article, newsletter, leaflet, and demonstrative days, and so on. So which was the best practice? The best practice was to increase the area for legume crops. So, in fact, reduce the soybean utilization in the farm, abandoning the monoculture and apply crop rotation. Increase, when it is possible, the double cropping. Is another important thing is improving the efficiency of crop conservation, the reintroduction of meadow, and reducing the chemical nitrogen fertilizer. That is all that is concerning the forage system. But this part is, of course, linked to the herd feeding and management. So because we have to produce forage but we have to produce a high quality forage. Because if you use a high quality forage, we can reduce, in fact, our impact. Another practice was the adaptation of innovative ensilage techniques, legume forage instead of soybean meal, precision feeding, optimal herd management, that means fertility, welfare, and disease. And also that is another important point that is, of course, linked to the forage production is the storage management, and that is very important, the timing of distribution, the manure. This is the result. This is the result on sheep and goats farm. We can see after 3 years, after applying the best practice, we can see the reduction of the impact of the part of this demo farm, and this result was obtained through the optimization of manure spreading management, so less chemical nitrogen, introducing the leguminous crop, in this case was vetch, and by using a quality forage and high quality forage as well. In the sheep farmer, the reduction was higher, and they focused on precision feeding and herd management. In the dairy farm, part of the demo farm applied the precision feeding, and part of the farm applied the agronomic practice. In the first group of the farm, we can see the precision feeding reduced of 5% the impact. The impact was calculated on the kilogram of CO2 equivalent for kilogram of milk. Okay, this is the index, and they obtained this result by using high quality forage. That means more desirability and with higher protein content, and legume forage instead soybean meal. The farmer that applied the agronomic practice, they reduced around 10% their impact, and they obtained the result growing leguminous crop, and they passed from 21 to 30% of agricultural area by optimizing the manure management. That means, of course, the reduction of nitrogen fertilization, and also they increased the crop rotation. So they used more crop in the crop rotation. Another project was the life agriculture that was finished in 2022. And this project investigates the contribution that animal husbandry can play in mountain area for soil protection and climate change mitigation. Also in this case, we defined the best practice and the protocol. The case of study was focused on the Parmigiano Reggiano DOP, and in which practice we were focused on the organization and the management on the forage and cropping system, the management of animal waste again, and the feeding and herd management. And the fourth was the management of the infrastructure in agricultural land, like drainage, farm mobility, and so on. And this is the result. Just to give you an example, where started the experiment started in 2020, where the field were first manuring, and then the field was sowed with a forage width with a minimum tillage. So we applied the technique of minimum tillage, and we sow the forage width. In the fellow years, we fertilized only with slurry, hacking, and then we passed to a direct sowing of fescue. Okay, so minimum tillage and no tillage. In 2022, we obtained a very good production. So because we have to remember that we are in mountain, so we had 7.2 ton per hectare, and then we passed to a direct seeding of lucerne and establishment of a permanent grassland development. So we applied the whole practice that we said before. So reduce the soil tillage, minimum and no tillage, optimizing the spreading, manure spreading, and increase the biodiversity, and use the crop and or genotype that is more adapted to the climate change. This is just outside of my time. Is the last two to slide. This is the project that finished this year in March. Was financed by the Emilia-Romagna region, and we tested 9 species varieties. Part is historical crop grown in our region, but part was crop from the region that was more drought, like Sulla, Sainfoin, and Commerbird's foot. And also we tested some agronomical parameter like seed density, and also some new techniques that the seed company are starting to propose to the farmer, that is to confect the seeds and use the inoculum directly in the seed. This is the results. We can see small, okay, alfalfa, okay, lucerne is the main crop that we use for forage production in our region, and the sunflower and clover and bird's food is not so used, and this is interesting because crop like sunflower and bird food and also sulla are crops that usually are grown in the South Italy, and in the past year was not cultivated in the north because of very cold condition. But now we had a very good production, and another important things is also the quality of these new species. Is also the protein content and the total protein that I can produce in with this crop. We can see also the the clover. Okay, we tested hybrid, repens, and pratense. That is interesting to cultivate alone. But this one, of course, we had this experiment just to have an idea if some, for example, we want to use it in the mix. So how this crop can contribute to the quality, and we can see clover repens, a clover hybrid. Yes, they don't have a high productivity, but they have a very high quality. So just to understand how this can be used in the mix. Okay, thank you very much.
Okay, great, Alessandro. There's two questions in the chat. I think one comment, one question.
Yeah.
Are we going to have the presentations later on? I think we will upload them, right? Or will just the recording be there?
Yeah, no, yeah.
Okay.
Yeah, we can share, yeah.
We can share the presentation.
Yeah, absolutely.
And the second comment is the carbon sequestration of grassland and improved carbon sequestration when grazed are separated from the livestock production in most greenhouse gas calculations. Just a comment, I guess.
Yeah. So you mean, sorry, can you repeat?
From Frank in the chat, it says the carbon sequestration of grasslands and improved carbon sequestration when grazed are separated from the livestock production in most greenhouse gas calculations.
So the carbon sequestration is I don't know, Frank, what if I were understood your question,
when you started your session, you said that they were included in the livestock production, the carbon sequestration of the grass. But usually when you do the calculations for livestock, you get your data from the carbon footprint of the crops that you feed. You get it from the database, and there you cannot see if the carbon footprint of the grass that you put into the animals, if it is grazed or not, and you cannot see either if there's carbon sequestration or not. So what I'm trying to say is that even though we would like the carbon sequestration to be part of the livestock climate impact, in the ways of calculating it at the moment.
No, I think no. There's the carbon sequestration was concerning only the forage production. And I think this quantity of the carbon was not included in the final result. You mean on Forage for Climate project?
Yeah. So in the life cycle assessments,
the
carbon sequestration is not included.
No. I think I have to ask.
But that's a mistake.
Sincerely, I didn't do that. I just show the result. Now I will check, and then I give you an answer more in deep, just to give you a correct